The world thinks silver is priced in New York. COMEX warehouses, spot prices quoted to the millisecond, but the supply? That is controlled somewhere else. On December 26, 2025, China released a list. 44 companies. That is how many firms will be allowed to export silver from China in 2026 and 2027. Not 44,000. 44. In a country that processes 60 to 70% of the world's refined silver. That is not a policy detail. That is leverage. Here is what this actually means. If you own silver, your asset just became more scarce, and that scarcity is now politically controlled. If you work in solar, electric vehicles, or semiconductors, your input costs just became unpredictable. If you are a trader, the fundamental pricing mechanism for this metal just changed. Because here is the difference between a ban and a license. A ban says, you cannot do this. A license says, you can do this if we allow it, when we allow it, and only through the channels we designate. One is binary, the other is a dial. And that dial can be turned at any time, for any reason, without announcing a single policy change. Think about it this way. If China banned silver exports tomorrow, the headline would be global. Markets would panic. There would be diplomatic escalation. But if they just slow down the licensing process, if applications sit in review for 60 days instead of 30, that is not a ban. That is administrative friction. And it works exactly the same way, except it is harder to protest, harder to prove, and gives the issuing government total deniability. As one analysis noted, delay is the new denial. According to Reuters reporting on December 30th, China named the companies that will be able to export tungsten, antimony, and silver during the 2026 and 2027 period, metals Beijing deems as critical to support its own industries. This is the control point that matters, not mine production, not reserves in the ground, but the choke point where raw material becomes refined product, where doré bars from Mexico or Peru get processed into 0.999 fine silver that can actually be used in a solar panel or semiconductor. And that choke point is in China. According to data from January through November 2025, China exported over 4,600 tons of silver, while importing only 220 tons. That is a net export position exceeding a 21-to-1 ratio. When you control 60 to 70% of global refining capacity, you do not need to own the mines. You just need to control the gates. Now, you might be wondering, why does Beijing care this much about silver? Silver has the highest electrical conductivity of any metal on Earth. Not copper, not gold, silver. And in a world running on electricity, where every efficiency gain matters, where every wasted watt is a cost, that property is irreplaceable. Let me break down the demand side, because this is where it gets critical. Solar panels. In 2024, industrial silver demand hit an all-time high of 680.5 million ounces, with solar energy accounting for more than 30% of that total. Each photovoltaic panel uses about 15 to 25 grams of silver in the conductive paste. That does not sound like much until you scale it. Global solar installations are projected to exceed 500 gigawatts per year by 2030. That could mean the solar sector needs 250 million ounces of silver annually. And here's the thing. As countries race to meet climate targets, solar is not optional anymore. It is mandated. The European Union, the United States, China, India, they have all committed to massive solar build-outs over the next decade. That demand is locked in. It is not speculative. It is policy. Electric vehicles. A conventional car uses about 15 to 28 grams of silver. An electric vehicle uses 25 to 50 grams, nearly double, due to battery management systems, power electronics, and charging infrastructure. But it is not just the vehicles themselves. Think about the charging infrastructure. Every fast charging station uses silver in its power electronics and control systems. Every level 3 charger, every supercharger station. As electric vehicle production expands, the automotive sector's silver demand could triple by 2030, and with countries like the United Kingdom banning new gasoline car sales by 2030, and California doing the same by 2035, this is not a maybe. This is happening. Data centers and artificial intelligence infrastructure. This is the sleeper category. Total global information technology power capacity increased by approximately 53 times, from 0.93 gigawatts in 2000 to nearly 50 gigawatts in 2025. And with the artificial intelligence boom, that is accelerating. Every new artificial intelligence training cluster, Every expansion of cloud computing capacity, every upgrade to 5G and eventually 6G networks, all of it requires more data centers, more servers, more switches, more high-frequency connectors. Silver is in the critical path because nothing else can handle the current density and heat dissipation requirements at that scale. When you are running thousands of servers in a single facility, generating massive amounts of heat, operating 24 hours a day, 7 days a week, you cannot afford equipment failure. And silver is what makes that reliability possible. It is not just about conductivity, it is about thermal management. It is about longevity. It is about reducing downtime in systems where every minute of outage costs millions of dollars. So here is the math. A few grams per device, multiplied by billions of devices equals a supply war. And this is not substitutable demand. You cannot just swap in aluminum or copper and call it good. Copper has about 95% of silver's conductivity, which sounds close, but in high-performance applications, that 5% difference is everything. It is the difference between a system that works reliably and one that overheats, fails, or requires twice the space for cooling infrastructure. Silver's unmatched electrical conductivity makes it essential for applications requiring maximum conductivity in minimal space, with no viable substitute for high-performance needs. When the International Energy Agency projects that solar photovoltaic will account for more than 80% of renewable power growth between now and 2030, they are not describing a trend. They are describing a dependency on silver, which is refined where? Now here is where it gets really interesting. This is the same playbook China used with rare earths in 2010 when they restricted exports to pressure Japan during a territorial dispute. And understanding that precedent is crucial because it shows you exactly how this strategy works. In September 2010, a Chinese fishing trawler collided with Japanese Coast Guard vessels near the Senkaku Islands, territories claimed by both countries. Japan detained the captain. Within days, Chinese customs officials began halting shipments to Japan of rare earth elements, minerals essential for everything from hybrid car motors to missile guidance systems. At the time, Japan was totally dependent on China for nearly 90% of its rare earth imports. The panic was immediate. China's total rare earth exports declined by 77% and global prices quadrupled. The price of samarium, crucial to high-temperature military applications like missile guidance motors, more than tripled to $32 a pound. Here's what matters. To this day, there is debate about whether China officially banned rare earth exports to Japan or whether it was just aggressive enforcement of existing quotas. Chinese officials never publicly announced a ban, but the shipments stopped. The customs paperwork sat in review. The approvals did not come through. That ambiguity was not a bug, it was a feature. Because if China had officially announced a ban, it would have violated World Trade Organization rules. There would have been formal complaints, trade disputes, international arbitration. But if shipments just happened to slow down due to administrative processes, that is much harder to challenge, and the perception was enough. As one academic study concluded, when pressed to provide an example of geopolitical manipulation of critical materials, the China-Japan rare earths incident of 2010 is invoked time and again, whether it was officially a ban or not. The template was set. China is now applying that exact template to silver. Same licensing system, same control mechanism, same strategic leverage, same administrative ambiguity. Japan responded with a supplemental budget of 100 billion yen to develop alternative sources and stockpiles. Companies invested in recycling technologies. Mining operations in Australia, the United States, and Africa received emergency funding. And it worked, partially. Japanese dependence on Chinese rare earths dropped from 90% to 60%. But here's the key detail. That still leaves them majority dependent more than a decade later, even after spending billions on alternatives. Because China still produced 79.55% of the world's rare earth supplies in 2021, despite having only 36.67% of total reserves. Why? Because it is not about what is in the ground. It is about who built the refineries. It is about who developed the processing technology. It is about who invested in the infrastructure when no one else thought it was strategically important. And with silver, the refining dominance is even more extreme. China controls 60 to 70% of global refining capacity. The West let that happen because silver was seen as just another commodity, a monetary metal, something you could always buy on the open market. Nobody treated it as strategic infrastructure, until now. And the market has already responded. Silver surged an estimated 150% in 2025, breaking above $80 per ounce in December. But this is not just about the spot price going up. It is about the market structure changing underneath. There are three things happening simultaneously. 1. Premium gaps. When you restrict exports from the primary refining hub, you create geographic price dislocations. Silver in Shanghai starts trading at a different price than silver in London or New York. That premium is not arbitrage, it is friction. It is the cost of getting metal out of China if you can get approval, if you can get the license, if your shipment does not sit in customs for 6 weeks. 2. Physical decoupling. Once physical delivery becomes the benchmark for price discovery, traditional futures exchanges like COMEX may lose control of global pricing altogether. When industrial users cannot rely on just-in-time delivery from the exchange, they start bidding for physical metal in private transactions. Silver lease rates in London rose to as high as 8 to 9%, indicating severe tightness in physical availability. That is not normal. That is the cost of scarcity. 3. Supply chain stress. One major United States refiner is reportedly turning away ultra-pure silver because capacity simply is not there. They have the metal, they have the demand, but they cannot process it fast enough because the infrastructure was never built to handle supply shocks. The silver market has run a structural deficit for 5 consecutive years, with demand exceeding supply by an estimated 149 million ounces in 2025. And now the primary source of refined supply just put up a licensing gate. You cannot print silver. You cannot create it with monetary policy. You can only mine it, refine it, and deliver it. And if any of those steps get bottlenecked, especially refining, the price has to rise enough to either ration demand or incentivize new supply. So what happens next? There are basically 3 ways this resolves, and you are probably going to see all 3 happen at once. 1. Western countries will try to build their own refining capacity. The problem? It takes 3 to 5 years minimum, even with government subsidies. And it might not be cost competitive without tariffs or ongoing support. That is not a free market solution. That is industrial policy. 2. Companies will try to reduce silver usage through substitution and efficiency improvements. The solar industry has already cut silver loading per panel by nearly half since 2016. But even as silver content per panel drops, total solar installations are growing so fast that absolute silver demand continues to rise. You are running to stand still. And in high-performance semiconductors, medical devices, or military electronics, there is no substitute at current technology levels. 3. Prices will rise to ration demand. If you are a solar manufacturer, you cannot just stop using silver because the price went up 40%. You eat the cost and pass it along, or you go out of business. So the price signal works, but it ripples through the entire clean energy transition. Solar gets more expensive, electric vehicles get more expensive, data centers get more expensive. What we are watching here is not just about silver, it is about the architecture of global supply chains in an era of strategic competition. The timing of these restrictions matters. China announced licensing controls on tungsten, antimony, and silver simultaneously. That is not coincidence, that is coordination. These 3 metals share something in common. They are all critical to defense applications, renewable energy infrastructure, and advanced manufacturing. And in all 3 cases, China controls the majority of global refining capacity. Tungsten is essential for armor-piercing ammunition and high-temperature aerospace applications. Antimony is crucial for flame retardants and military equipment. Silver, as we have discussed, is irreplaceable in solar panels, electric vehicles, and advanced electronics. China is not picking these metals at random. They are choosing the ones where they have processing dominance, where Western dependence is highest, and where substitution is hardest. This is not environmental policy. This is resource diplomacy. And the licensing model is brilliant precisely because it is adjustable. They do not have to ban anything. They just control the flow rate. Turn the dial down during a trade negotiation. Turn it back up when relations improve. Use it as leverage in disputes over Taiwan, technology transfers, or market access. The mechanism is in place. The precedent is established. The playbook is proven. For Western governments, this creates a strategic dilemma. Do you build domestic refining capacity, even if it is more expensive and takes years? Do you stockpile physical metal, tying up capital and inventory? Do you accelerate research into substitutes, even knowing some applications have no viable alternatives? The answer is probably all 3, but none of them are fast solutions. And that gap, that window where you are still dependent but trying not to be, that is where the leverage lives. For traders, this creates a new baseline assumption. Physical supply risk is now permanently priced into industrial metals. The days of assuming just-in-time delivery from the lowest-cost global source are over. You either pay up for security of supply or you accept the risk of disruption. And here is what most people miss. This is not just about China. Once one country successfully weaponizes control of critical material supply chains, others will follow. If Indonesia controls nickel refining, will they implement similar licensing? If the Democratic Republic of Congo controls cobalt, will they create export restrictions? The model is now proven. The incentive structure is clear. Expect more countries to realize that controlling processing infrastructure gives them geopolitical leverage, regardless of who owns the mines. Now remember, I mentioned something happened in November 2024 that almost nobody noticed, the so-called silver crash. Except it was not really a crash, it was a margin trap. And the way it played out tells you everything you need to know about who controls the paper market and what happens when physical and financial silver start moving in opposite directions. That is the next video. If this analysis helped clarify what is actually happening in the silver market, hit subscribe. We are building a library of deep dive content that does not just repeat headlines. We are connecting the dots across trade policy, market structure, and real-world supply chains. Thanks for watching. See you in the next one.